Hey, I want to do a quick video on my solar system there. I've got two monocrystalline 300 watt panels. They're actually designed for 24 volt system. And let's run in the house here real quick. Take you with me. I don't know how to edit these videos yet. Maybe I'll be able to edit this out when I figure out what I'm doing. And hopefully you won't have to walk with me around the yard here. But it's 4/9/14 here, and we're on a partly cloudy day at 12:30 p.m. Walk in here and we'll see what our voltage is doing. We're at 13.8 volts, and I'm also going to show you my my furnace modification. Kick the furnace on there. Turn on the solar light here. And the furnace is starting to kick on. Turn on no light, it's not running on solar. I'll show you here. The furnace is starting up. I'll try to get in here and show you my spark ignition system. It should be lighting. There you can hear the buzz. There you can see the reflection off the spark anyway. And we should have ignition here any second now. Light the camera up a little bit. Every now and then it don't want to ignite, and that is one of the times, of course. It'll relight. It normally lights up right now, but for some odd reason, I have no idea why, it hasn't been wanting to ignite properly. Tweak it over a little bit, maybe it moved on me a little bit. Should light right up now. I've had this in operation the entire winter. I think maybe I didn't get the screw tight in it. It's been moving on a little bit while I've been in here. And we should have ignition in 3, 2, 1, ignite. There we go. You can see how quick it normally ignites. You can see in here. That's my igniter right there. You can't see the spark. The spark's up higher than that. Get a view of that in there. That's actually what I had one of these laying here. One of these right here. And it was broken, and it actually, used it for a long time with it just broken, and used the gap across the center too. And then it started getting a little bit corroded, and I put a piece of copper wire on one side. It worked a whole lot better. All right, now my furnace is running, and you can see my grid tie inverter here is happily chugging along. We'll go over to my kilowatt meter. Get watts. And right now, like I say, it is a cloudy day. My batteries are low. Right now I'm pushing 176 watts back into the grid, which is really low. I've seen it as high as 400. It generally averages about 300 watts while it's running. And what I've got going on for my panels, I've got my wires coming in here. Go over here, we've got a Xantrex. Got the cover off of it, but there's a vent there. Xantrex C35 charge controller, designed for 12 or 24 volts DC. And I've got 470 amp hour AGM batteries, and I've got two 100 amp hour AGM batteries. Kick another light on here. This is my 6,000 watt inverter, and I just put this on here yesterday, and somehow I'm pulling 3.1 watts off of something. I'm not sure what. Oh, I've got the light on, that's why. This thing is pretty accurate. It's not perfect, but 3.1 watts, that's the one light burning that I turned on when I come down the stairs. And so far I've been saving 3 cents every 30 days and 40 cents a year. I just hooked this up like yesterday, and I've not used anything like yet. I haven't used the coffee pot or the toaster oven or anything. So I've got my inverter actually wired into the breaker box here. and I had to disconnect the neutral. If you try to do this, I learned this hard way. If you try to hook an inverter into the breaker box and just hook the neutral to the neutral without disconnecting the neutral from ground, you will fry the inverter quickly. I've actually had to rebuild this inverter here, and another one I fried it also, and there was no hope for it. It's a parts bucket. So got this wired in, and right now it is supplying the power for my downstairs light that I turned on, the dining room light, which consists of three, I think are 8 or 9 watt LED bulbs, and then I've got the gas cook stove runs on it, the toaster oven, and the coffee pot, and 2 lights in the kitchen, as well as another receptacle in the dining room. So I don't want to load the system up too much just yet. It's early in the season, but I want to keep it to where I can, whatever I'm running on, I want to be able to run all year long and not have to worry about it. I've also, up here is my wireless router. It's running directly off of 12 volt DC via these little boogers you can get off of eBay. You can see they're 15 watts and they convert 12 volt DC down to 5 volts, 3 amps max, and it is cool as a cucumber. It's been running at for well over a year. Up here I've got my cable modem, and it's been running for well over a year on this system, directly off 12 volt DC. And this is the genius of the system here. Let's start here. This here, where my kilowatt meter is, this is going to my grid tie inverter. The back side of this here is going to, it's wired directly into my furnace blower, right now on a low speed setting because it's winter time, or it's springtime actually. And it's running directly into that blower, so that when the blower kicks on, it turns on my grid tie inverter here, which is still plugging away happily. Now another thing it does is it supplies power here. This runs up and over to a relay here, and I've got another relay coming, should be here any day now. And what this relay does, it's normally closed, and when it's energized it opens, so it disconnects the power from my battery bank and shoots all the power via this diode right here to my grid tie inverter and to 2 100 amp hour AGM batteries. I've got a, I believe it was like a $23 charge controller here off of eBay. You can see here it's 12:30. These batteries have not had any charge at all today, or yesterday for that matter. It was cloudy yesterday. My batteries are still in a decent state of charge. This will actually turn orange, and then it will turn red when the battery is completely discharged. And right there, it just now turned orange. I've also got a capacitor here that helps to smooth out the pulse. What happens is when the system goes into bulk and gets over bulk setting, it will, I love it when the phone starts ringing when I'm trying to do something. It will pulse, and it will give this diode a pulse. Let's see, this piece of metal here is a heat sink, and it actually does get pretty warm. So that capacitor there smooths out that pulse, and every time it pulses, that capacitor charges, and every time it's on its on pulse charging my 12 volt batteries, the capacitor discharges and allows these batteries to get a more steady flow of current. And I'm going to take you upstairs here after I turn the lights out. Can't leave lights on. I'm going to show you my television set. Wait off. Into the house we go. And this wiring needs some tidying up here. I got all my seeds laying on the floor. And you can see we're still at 13.1 volts, and right now the furnace is running and I'm not charging at all. Matter of fact, I need to turn that furnace off. We'll let it run for a minute. Now, got these little boogers off eBay. Handy little box. It will step up 12 volt DC to, I think, 36 volt DC. And if I remember correctly, they're supposed to be good for 100 watts. 100 watts is 100 what I call Chinese watts. I would say realistically you're looking at probably 75 watts unless you put a fan on it. I've got a smart box here. The smart box runs directly off 12 volt DC. I've just got this wired in with a little plug here where I can plug it in, or I can plug in my amplified antenna here. In behind the TV I've got a switch box, and I've got a antenna going to it with a power inserter going up to the amplifier on the antenna, located near the antenna. This is my television set. We'll kick it on here, show you. This is a straight 12 volt DC, and we'll let it fire up there. We'll show you what it does. Westinghouse. The reason I chose this Westinghouse TV, it's a 39-inch. The reason I chose this TV...
Brian at 304-926-4945. Beautiful home and a great...
was that it runs on DC most of all, but you can see the picture, everything works just perfectly fine. I can plug the smart box in if I want to, or I can plug the antenna in. But right now I'm running on cable. You can see I've got a little glare from the sun. But I've also got emergency lighting, which I can actually use every night. This is a camper light, again off of eBay. If you search RV light fixture, it's LED. I think it pulls 3.8 watts. It puts out really good light. I was going to mount it on the wall, but I figured out that if it's laying right here, one, I don't have to mount it. Two, I can pick it up and aim it if I need to. I need to put a little longer cord on it. But another thing, these little connectors here are pretty handy. I got off eBay. They weren't very expensive at all, and I bought like 20 of them. And the seller didn't send me all of them. I had to get on to them. They sent me the rest of them. But one thing, word of caution with these type of plugs. I have fried 2 computers doing this with not necessarily this type of plug, but once I did. You can see the end here has a little bit of metal sticking out right there, and my system is grounded to my electrical system in my house, and therefore when I've got my laptop, not this laptop, another laptop, hooked to my stereo equipment, it's getting the ground via this plug right here. So what happens is when you try to connect this plug here up, if you had that connected and you hit this, let me get focused in on here, and you hit this outside edge with this connector, it's going to arc because you've got a hot going directly to ground. Well, that ground is going through the computer and trying to go in the audio jack, and it will fry your audio circuit quickly. I've done it twice now on 2 different computers, and thankfully one of them has a automatic sensing thing where I can hook it into another jack, and the other jack works just fine. I'm sure it's probably repairable, just a little blowed spot on the circuit board probably. But that's my solar system, that's my TV. Anybody has any comments on my spillover system? I'd love to hear from you. I think it's a pretty ingenious idea, because on a typical solar system, when the batteries get charged, the power is just being completely wasted, and in my case the power is being scavenged and reused for my, and you can see I'm at 12.5 volts right there, and I'm going to kill the TV and show you what the voltage does. And I've got no charge going in, but the TV does pull it down quite a bit. As soon as I kick the TV off, we're right back up to 13 volts with no charge going in at all. I'm going to turn the furnace off real quick, and I'm going to show you. Come on, furnace. There we go. Turn on 64. It's going to be a warm day anyway. I'll show you when this furnace kicks off how quickly my voltage with 2 panels, it's sun shining pretty good now. Got some really good stuff. While I'm waiting on that furnace to kick off, here's some stuff that's really nice. This is called Reflectex, and it's basically Mylar coated bubble wrap. And you can put this stuff in all kinds of places. You can cut it with scissors or a utility knife really easily. It's just thin stuff. It don't take much. I cut it a little bit big on that. I put it on the bottom of both the storm doors, and it does a really good insulating job. Sucker should be ready to kick off any second now. We'll show you this voltage. This is what the voltage does when the furnace kicks off on a sunny day. And we're at, I have a hard time focusing this thing, 1241 and April 9th. And I just changed my panel angle yesterday to 60 degrees. And it was time for me to change the panel angle there. Sucker should be kicking off any second now. Blower scavenging the heat. There we go, blower just kicked off, voltage immediately jumped to 13.2, and it shouldn't take but a second, it should be climbing 13.3 pretty quick. It's going to stay around 13.2, sun's dipping down just a little bit. But any comments, feel free to make them, and if you'd like to make a donation, I'm always up for donations. I just give you my email address there, and we accept PayPal.